Daily we speak about saving the environment and our world by reducing our energy consumption and looking for new sources like geothermal energy, energy from waves, wind energy and solar energy. From a scientific point of view, we distinguish different forms of energy. The most known are potential energy and kinetic energy, but also internal energy of a system is important. The internal energy refers to the thermal movement of molecules in any material. So has water of 25 degrees Celsius another internal energy than water from 50 degrees Celsius, because the molecules move much faster at higher temperature. From thermodynamics we know that for liquids in a constant volume, the change of the internal energy U per unit of mass can be written as the product of the heat capacity of the fluid and the temperature difference. So we have to add 104.5 kilojoules to heat up 1 kilogram of water from 25 till 50 degrees. In many practical situations, energy transfer occurs at many different places around us. For example, heat loss to the surroundings or work that is performed by a pump. Each time we have to deal with different types of energy. We will now set up a general energy balance of a continuous process where a fluid enters and leaves the vessel. The liquid in the vessel is well mixed with the stirrer and is kept at a constant temperature by means of a heating element. This type of vessels are often met in the process industry, where raw materials are converted into consumer products. The law of energy conservation tells us that no energy is lost. This means that if the total amount of energy in a certain volume is constant, we know that the energy which enters the vessel also leaves the vessel. Or in a more general way we can formulate this as follows. The change of energy in a system as a function of time is equal to the amount of energy which enters the system minus the amount which leaves the system. If we look at the general formulation of the energy balance, we see that this one is similar to the one of the mass balance. Let's now look at the total energy balance of the vessel. Earlier we already talked about 3 different types of energy. This means potential, kinetic and internal energy. If we sum up these energies and take them all per unit of mass, we can introduce the so-called energy concentration E. If we multiply this energy concentration with the mass flow rate, we obtain the amount of energy which flows into the volume, and in a similar way we obtain the amount which leaves the volume. However, this is only a part of the total balance, because we have also to take into a few other energies into account. The heat added to the vessel by the heating element, phi Q, the work performed by the stirrer, phi W, and the pressure energy. The last mentioned energy is related to the mass flow rate in and out of the vessel performing work against to the prevailing pressure. That means that the work done by the fluid is equal to the product of the local pressure, the surface area of the entrance, and the velocity of the fluid. In other words, this product can be written as the product of the pressure over the density and the mass flow rate. If we now sum up all the terms of the energy balance for the considered volume, we obtain the following formula. We now see that the change of energy in a system with an inflow and an outflow of fluid consists of 4 terms which are dependent on the mass flow rate and 2 terms which are not dependent on the flow rate. If we combine all the terms which are dependent on the mass flow rate, we get the following formula. We have to remember that the energy concentration E consists of the sum of 3 types of energy: the potential energy, the kinetic energy and the internal energy, all per unit of mass. After substitution of the energy concentration E, the total energy balance can be written as. We have to realize that in this example of the vessel, we assume that no heat is lost to the surroundings and that no heat effects occur as a result of chemical reactions. It's now important that you make yourself more familiar with all these terms and their meanings. Answer the questions and make all the exercises. In the next video we will give examples how this total energy balance of an open system can be used to solve different types of problems. Thanks for your attention.